Okay. All right, I think we're ready to go. Thank you very much, everybody, for joining us here at Ignite. My name is Mark Weitzel. I'm one of the product managers for Redis at Microsoft. I'm joined by my colleagues Shruti and George, and from the Premier League, Simon, who will be talking about how we use Azure Managed Redis. We've got a number of topics for you today. We're going to walk through some of what Azure Managed Redis is. We're going to talk about the Premier League case study, some of the very, very cool things they're doing, and I don't know, something they brought here. And then we're going to have like demos and demos and demos, and then we're going to kind of talk through how you can use Azure Managed Redis in building some of the new AI applications that you're all working on. So quick show of hands, how many folks know Redis? How many? Okay, oh yeah, okay, great. Not surprising because it's really loved by developers, and what we're starting to see is developers taking the tools that they know, that they love, that are trusted inside the enterprise and start to apply them for these new AI use cases. Now, another quick show of hands, how many folks know Azure Managed Redis? Oh, great, that's fantastic. So you know this is where we're investing, and recently we retired or made a retirement announcement for our OSS and Acre, what we call Acre, Azure Cache for Redis Enterprise SKUs. And this is the fully managed, Azure Managed Redis is a fully managed first-party offering of Redis inside of Azure. And this is where we get our high performance, low latency, in-memory data storage. And this is where we're putting all of our investment for new things, and it's actually less expensive than our other SKUs. And in some cases can be significantly less expensive. And you can get the with geo-replication, your 5 nines that you're looking for. The other thing that we talk about when we think about Redis is how the Redis has evolved to handle many of the new use cases that we're seeing in the internet. You know, if we go back to 2014, you know, we were talking about user session store, we were talking about pub sub. Now we're talking about vector search and RAG applications and semantic caching. So all of this has changed, and we've really moved from this notion of this data cache to a real-time data platform. Now, I've done enough talking. Let's see some of Azure Managed Redis in action. So I'm going to ask Simon and George to, oh, wait, hold on. Let's get this baby out. Now, I'm going to ask Simon and George to come up.
Simon.
Good afternoon. I'm Simon Brown, Digital Architect from the Premier League. I travel with this trophy wherever I go. And today I'm just going to give you a brief demo of the Premier League companion app. And so this is an app that we have built and launched this year. We started in January, I think, this year, working with the Microsoft team to build an AI-powered, personalized and tailored app for the 1.8 billion fans around the world. And so this is our starting position. And this is the demo here that we're flicking through now. So you can sort of see we went from closed prompts. We've just launched free text prompts, so you can ask where to watch the game, do things like that, and basically have this conversational experience with the app. And then further down the line, we're looking at AI-generated narration, so we want to improve accessibility. So you can see that here, and then we're going to look for multi-language and localization. So we want to target the non-speaking addressable market, and then after that, we're going to look at things like personalized video. So personalized video is a big space where we've got this massive archive, and we want to look at ways of using AI to basically generate personalized clips, vertical video, and everything in between. And so that's what we have been working on with these guys. And over to you, George.
Let's wait for the video to finish. Fantastic. So we had the incredible opportunity to work with Simon and the Premier League team in the sport that we love and create engaging, fun experiences at a scale that only a few products can reach. As Simon mentioned, we're talking about 1.8 billion fans worldwide. So as we see here in the screen, this is the guided prompt experience. So when users land on the product, they see 3 prompts from an inventory of millions of curated prompts. These prompts are tailored to the fan experiences and interests, which means that registered fans who are Liverpool fans will experience Liverpool-related prompts, while Manchester United fans will experience Manchester United-related prompts. And these prompts change across time, pre-game, during game, post-game, in season and out of season. In the second screen here, we see the response, along with relevant references to articles and videos. And in the last screen, we see the follow-up prompts, which are carefully created in a way to create an engaging experience, where fans are going to click on these prompts and continue interacting and enjoy the sport that they love. The challenging part of this project was that we had to build secure, personalized, and up-to-the-moment experiences. And one of the toughest parts was that for all these steps that I just described, we had the non-functional requirement to provide full responses in under 500 milliseconds. So in order to enable that, we created an architecture that balances precision, freshness, and can scale massively. In this architecture, we have Cosmos DB, where we created optimized data models for efficient querying. Then we have created agents using semantic kernel that are using various tools to query historical stats and content information. And they're consuming this information from Azure AI Search and Cosmos DB. We used semantic kernel to develop these agents, and this was the framework to use when we started this project. However, the ecosystem is evolving very fast, and today we would use the agentic framework. And this is very much built on the same principles, but it offers some additional capabilities when it comes to developing agents. So then Azure OpenAI consumes this information and produces responses that conform with the Premier League editorial guidelines. These responses are then going through an evaluation step, where only those responses who pass certain criteria make it to the prompt catalog, which is our inventory, for serving the users. And we have Foundry in the solution as well, where we also enabled the tracing capability, which not only enables us to monitor the quality of the responses, but also to see a lot more on the observability of how the system behaves across the board. And the service that was core to this orchestration that enabled us to serve the scale of the Premier League traffic is Azure Managed Service. This is where we store the prompt catalog for fast serving for the users. So Azure Managed Service is used for the guided prompts, for the responses, and also for storing and retrieving the conversational history of the users, because this is also what we use for the open prompt capability. This is the service that enables us to manage and perform and provide reliable and fast responses, even at the very seasonal spiky traffic that we see with Premier League. And when we performed some load testing for this service before we went for the release, we did fire or simulate 6,000 requests per second for a sustainable period of time, and we were able to serve 95% of these responses in under 80 milliseconds. So thank you, Simon, for being today with us here, and thank you to the project team. And with that, I will pass to Mark, who is going to tell us more about Redis.
Thank you very much. You want me to take, I know you're a Man U fan, should I? All right, okay. All right, so thank you very much. I'm going to ask Shruti to come up here real quick and show us her face so that we can get to the next session. All right, so many of the things that they talked about in building that application, one of the things that happens is these things are changing very quickly. And quick show of hands, how many folks are building agents and AI stuff now today? Yeah, okay, not surprising. And so the challenges that we have is, we have to keep up with the things that are changing around us, not just new models and things like that, but also, on what the Premier League started with was semantic kernel, and now we have agent framework. So this space is moving and changing very, very quickly. And so if we think about it, there's really 3 areas that we focus on where Azure Managed Redis can really, really help. First is in the cost management. We'll talk about that shortly, but also adding knowledge and then helping you leverage those frameworks like agent framework that we just saw. So let's talk a little bit about cache management or cost management. And here is what we would call our kind of traditional data caching scenario. This is, circa 2014 on up into the last few years, where you have an application, your application talks to the cache. If nothing's in the cache, then you go to the database, pull it back, put it in the cache, and return to your application. This is something that we all know and are very, very familiar with. In the AI world, though, you're not talking to a database. You don't have something that returns sort of that deterministic result. You're talking to an LLM. And so now what we have to do is we have to get some embeddings, and we take those embeddings and we put them in our vector database. And that's how we do the semantic search. We actually look for the meaning or the intent of that. And so what we end up getting is the same benefits. We get the fewer tokens that we can use, so it helps manage the cost of that. We get faster response and higher throughput. And so let's take a look at that in action. So I will flip over here. Great. And so here is a simple application, and the simple application is going to do 2 things. The first thing I'm going to do is I'm going to send a prompt off, and it's going to send one prompt not through the cache directly to the LLM, and then it's going to send another one to the cache, and we can start to see the results. So I will simply ask, what is the Premier League? And there's an ongoing joke that I can't talk and type at the same time, so there we go. So let's just see what happens here. Okay, so a number of things happen. We send the result, we send the request, it goes to our LLM, and on the left-hand side, you'll see that we get a result back. We've used about 92 tokens for that. We've got some cost in there as well. And you can see that little button or that little label on the bottom there that says that's a cache miss, because there was nothing in our cache. That one's not going to the cache. Now, if we look on the right-hand side, we can see that's also a cache miss, but it's still very, very quick. Like the latency is still very fast, even though we checked the cache first. And so now let's ask the question slightly differently. What is the... See, I can't talk and type at the same time. I can't type apparently at all. So now let's ask that question the same way. And you can see, or indifferently, and you can see on the left-hand side, that's a cache miss. And I've eaten up some of my tokens there. So now I'm spinning tokens, I'm building up costs, and I have a high latency because I'm hitting that LLM all the time, and it has to churn through and process that request, eat those tokens, and then return that to me. So that's a cache miss. On the other side, you can see that we actually have a cache hit. So here I've spent 0 tokens. I've returned it much, much quicker, and I've actually started to save money here. And so that's a very simple and straightforward way to start thinking about how semantic caching and the capability of Azure Managed Redis can help you manage those costs over time. You can also see that we have the similarity threshold here, so you can actually tune that. And behind the scenes in this example, we used Azure App Configuration so that we can actually tune that dynamically if we wanted to as well. All right, so that's one example of how we manage cost. The next example that we have is really thinking about customized knowledge. And for that, I'm going to ask Shruti to come to the stage.
Thank you, Mark. So I'm sure everyone here agrees that, sorry. I'm sure everyone here agrees that agents are not just LLM calls, right? Like the agents need to act, reason, and then also automate. That's what makes the agents powerful, not just LLM calls. And to do that, agents usually take an input from a user, some event, or some trigger that starts off this process, and then agents heavily rely on tools, external tools that provide knowledge, memory, or allow the agents to do some external automated actions. So that's what actually, that's the group of everything that you see here. That's what makes the agents more powerful and not just LLM calls. So as you can see, the tools are the most important part for the agents. And without the tools, agents will lack business context, and they won't be able to drive outcomes. And tools give the agents the ability to automate these external tasks, and that leads to higher productivity. But at the same time, we don't want developers or enterprises to be building a lot of custom tools or customizable tools as well, because that will slow down the adoption if you have to start writing every tool in a custom way. So what organizations need is a pre-built, customizable, but at the same time, an action-oriented tool that will help them integrate their business systems. And how do we do that on Azure? So your answer is Foundry. Microsoft Foundry is that flexible, secure platform that empowers enterprises, startups, and pretty much every developer to build the future of AI. You can use the developer tool of your choice. You can use GitHub. You can use Visual Studio, Visual Studio Code, Copilot Studio, any developer studio any developer experience that you are comfortable with, and then you can build powerful solutions with that. So Microsoft Foundry is that platform which brings agents, models, services, and tools together in a unified experience. And the latest here is the Foundry MCP Tools catalog that was unveiled yesterday. It is essentially a catalog of over 1,000 MCP tools that you can use in your Foundry agents. And obviously, as you can see, Azure Managed Redis is one such tool that you can integrate with your agents. With this integration, you can add a custom knowledge store to your agent, or you can also use your Redis instance for the memory or the context, storing the context in your Foundry agent. I have a quick demo to show how to set this up or how this works. So let's look at the demo. And as you can see, this is the Foundry, the new Foundry portal. And I'm going to be creating an agent here. So this is a very simple agent that I have. It's a Foundry agent. It's a travel assistant. I have a model that's associated or configured that the agent will use. And this is just a simple prompt that I have. It's a travel destination recommender. Imagine I'm some airlines and I'm building some travel destination recommender for my users. So if this is the agent, and right now it's not augmented with any external tool or anything, it's just an LLM right now. So if I do that and say I want to, one of the user comes in and asks for recommendations for beach locations, we can see how the LLM responds to that. OK, these are some very nice locations. Bali, Santorini, Bora Bora. I would love to go to any of these locations. But I am an airlines, and I have some deals going on some say, few locations. I cannot recommend these locations, but I want to recommend only a handful of locations to my customers. How do I do that? So you can do that through adding Azure Managed Redis as an MCP tool. So the way to do that is you can see that I have a tool that I've already created. This is a Redis MCP server, Redis remote MCP server that's hosted on container apps and has been configured as a tool. And I will be using this in my travel assistant agent. So now my agent has this new tool that shows up here. And then I'm going to tweak the prompt a little bit to say, always recommend locations from destinations knowledge store in the Redis MCP tool. And what exactly is this destinations knowledge store? It's essentially a vector database in my Redis instance that's connected behind the scenes. So this is my Redis instance that I have exposed through an MCP server. And it has a list of 20 different destinations that I have preloaded in a vector form with an embedding. So for example, this is Grand Canyon, this is Nantucket, Joshua National Tree Park. There's some handpicked 20 locations in the US, and those are the ones that I have deals going on, and that's the only recommendations I want to provide. So we have now exposed these locations as a tool to the agent. And that's it. These are the only two changes I make to my agent: change the prompt, add the tool, and then I hit the save button. And now we'll do the same call to the agent. Now this time, the result will be augmented by the data that we have in Redis. So as you can see, now that we have a tool that the agent is expected to look into, it will make this call into the MCP server to look for beach locations in the destination. So this will be a vector similarity search that happens behind the scene. And it's completely powered by Redis and its Redis search module. And if I approve it, it will recommend only 5 destinations that I have in my vector store. So that's the way you can augment your agent to look at only the data that you provide or your enterprise data, and not make recommendations based on the data out there on the internet or whatever it was trained on. So yeah, that's the power of adding Redis as a knowledge store to your agent. So moving on to the next challenge. Getting back to my slides. All right, so so far we have seen the cost management, how Redis helps with the cost management with semantic caching. The customized knowledge store is just that we saw how we can have Redis exposed as an MCP tool for your Foundry agent. And next up is the Microsoft Agent Framework. Mark, do you want to enlighten us about it?
Yeah, I just want to say, yeah, I was the one who said you can't go to Bora Bora. Sorry. I know you had really wanted to.
I know, but yes, yeah. I have deals only for destinations within the US
North
right
Dakota.
now.
Anyway, all right. So the Microsoft Agent Framework, I know there were a lot of sessions on that today, but it is one of our new offerings. I think it came out in September, where we talk about an open source runtime, and it's really designed to help building agents make the creation and orchestration and deployment of these things very, very simple. And it's really the unification of autogen and semantic kernel. So you get the great enterprise stability of semantic kernel, and you get that sort of experimentation and orchestration of autogen. And what we're going to focus on today is how Azure Managed Redis can plug into that to really provide 2 capabilities into the agent framework. The first is that short-term working memory. So if you think about the application we saw earlier from Premier League, this is the conversation that the user's having as they're interacting with the agent there. It's that play-by-play, if you will, of the current action. It has the history, the state, all of that. But in order to make this a very rich experience, what you really need to have is that durable long-term memory, so that the agent can learn about you, about your preferences, about the things that you like to do. And in this case, that's how you make your agents much, much more useful. So let's take another look at the travel agent demo, and we'll expand it a little bit, and you'll see a couple of interesting things here. First, again, you have a user interacting with your agent in some way, and that travel agent now is going to look inside of Redis, and it's going to use the chat message store, which is part of the agent framework, to pull up the session. It'll build that up as it goes, but it will also use the Redis context provider, which has the interface to the long-term memory inside the agent. It's going to pull those things in to determine what tools that it can use or what tools that it needs to use to provide that context. And we're also going to be using the Dev UI, and the Dev UI is a new capability from Agent Framework. And for that, I'll let Shruti take it away.
Yep, thanks, Mark. So this is the Dev UI that Mark mentioned. This is a UI that comes inbuilt with the Agent Framework. You just need one line in your code to enable it, and there you have it. As opposed to the previous demo where there was literally no code involved, it was just prompts and adding a tool, this is where you can have more custom tools and more complicated scenarios. So Dev UI is essentially the UI that developers will use when building an agent. So you would see anytime an agent is being used, any conversation you have with the agent, you will literally see the tool calls, the traces happening on the other side of the screen. So this is also a simple conversational agent that we have. And here, like Mark mentioned, we have the two Redis as a long-term memory and Redis as a short-term memory scenarios that we are demonstrating. So to demonstrate the Redis being used as a long-term memory scenario, what we have done is we have preceded this demo with some preferences, user preferences. So for example, if I start interacting, saying I am Shruti, because that's how it will know who the user is. And if I just say what are my preferences, it will show the preceded preferences in there. So this we have preceded it as that I always prefer to look for kid-friendly activities whenever I travel, and I'm a connoisseur of food tours and wine tours, so that's what my preferences are. So with these preferences, anytime I try to ask the agent to build me a trip or build me an itinerary, these preferences will be fetched from the Redis long-term memory that we have configured behind the scenes. I can show you that as well. So this is the Redis instance that is configured behind the scenes, and these are the preferences for me. So I prioritize kid-friendly activities, and the second one is I love food tours. So these are some long-term preferences or long-term memory that have been pre-configured here. So based on the preferences I have, let's start planning a trip and see how my preferences are taken into consideration. So let's say I am going to San Diego.
Notice you didn't say Bora Bora.
Oh, I know how to limit my aspirations. Everyone can dream to go to Bora Bora, but this is the reality. And especially with kids, I would prefer a smaller. Like I have a toddler, and I don't want to take a 15-hour trip with her. But anyway, so as you can see, if you look at it on the right side, there's multiple tools that were called to produce this response that you are seeing. Let's quickly look at the calls. There's a user preferences call that happened. This is where Redis was called. The preferences stored in the Redis Azure Managed Redis instance were retrieved, and this was the result of what was retrieved. And there were more tool calls that happened to research the weather, to research activities, to research the destination, and the agent was able to consolidate the responses from all of these tools into a single coherent response here. So as you can see, what I have been shown as recommendations is definitely there's a lot of kid-friendly attractions, but then there's also food tours that align with my preferences. So that's the power of using user preferences to provide customized recommendations or customized responses to your users. And if I just say, yes, the zoo sounds amazing, store my preference. So basically, I'm saying the agent, or I'm adding another preference to the Redis instance behind the scenes that, oh, I prefer zoos, so next time do include recommendations around zoos as well. So in the past, there were just two preferences for me. Now a third one shows up here, which is that I like visiting the zoos. And all of this is taken care by the context providers that are present in the agent framework. And in addition to the long-term memory, there's also the concept of short-term memory that Mark mentioned. That's the storage of the conversation history. So all this conversation that we had just now has also been stored in the Redis instance as the conversations. So this was just by adding a Redis chat message store, and that's it. Everything all the conversations you have with the agent are automatically stored as short-term memory in the Redis instance that's behind the scenes here. So that was the Dev UI. So essentially, if you are a developer, you are developing an agent, you can see the tool calls that are happening behind the scenes. That's great. But what if you want to know how many times is the agent being called. You want to know how many tokens are being used by this agent when other users are using. You want to have more observability and more insights into how this agent is actually being used. So for that, there's a new Agents Blade in App Insights where you can automatically get all the metrics for your agent runs. So you can see the traces, the agent runs, the models that are being used, the tool calls that are happening. You can also see the token consumption, the input versus output tokens. So this is all inbuilt, and this happens through OpenTelemetry. So it's like one line, and you enable OpenTelemetry on your agents, and you get this kind of observability out of the box for all your agents. And if you need more deeper insights or even richer visualization, there's this new Explore in Grafana button that also has been added recently. And if you click on that, you can see even more richer metrics and better observability here. You can literally see all the calls that are happening. You can debug anything that you think is not going well. I think it is not loading for me anything at the moment, but you can look at the trace. Yes, you can pick any of the agent run here and literally see all the calls that are being made behind the scenes here. So it's not, so as a developer, the dev UI makes your job easy to do the development, figure out how it's, figure out what calls get made. This simplifies the inner loop, and the observability dashboards that you have with Azure Portal and Grafana that will help you when you have more users using the agent. So yeah, that's the story here for improving productivity and observability for your agents when using Redis. What's next?
What is next? I think we have, so there we go. So here, that was a demo. So we're sort of recapping the things that we've seen so far. So the first that we have is the cost management, where we talked about how semantic caching can help you gain more efficiency in your application, can help you save costs as well. Then we showed how you can use Azure Managed Redis to bring knowledge into your agents, to enrich the experience there. And finally, we looked at how we can use agent framework and drop Redis in seamlessly so that you have a very rich interaction and that the agent actually learns who you are as you go. I think we left plenty of time for questions here at the end. And so there's a couple of next steps that we've got here. First, if you want to learn more about Azure Managed Redis, the easiest thing to do is simply ask Copilot. Tell me about Azure Managed Redis. If you want to learn more about the Premier League, you can also ask Copilot. Tell me about the Premier League. And then get started. There are all of these examples that we showed today are in GitHub. And so you can get started quickly. We've integrated with the Azure Developer CLI, so you can just do AZD up, and all of the examples that you see here will be running in your environment. We also have folks from Azure, the Azure Managed Redis team. Our engineers are there, and Redis Inc. as well. So if you'd like to talk to Redis experts, you can see us at the booth. And at that, I think we've got a few minutes that we can take some questions. So questions? There's a microphone there. Oh, that was timely right there.
So if we have a couple minutes, do you want to show the calculator that we have?
Oh, right. I did. I went right over that. Yeah, yes. I went right over that. I can't believe I forgot that. You should have called that out. OK. So when we talk about the semantic caching that we did earlier, I went very, very quickly, and I forgot that. One of the things that we had, we went back and we were talking about the Premier League. There's this little calculator that we have here. And one of the things that you can actually do is look at your hit rate. I think I can do that. Yep. And so one of the things that you have is you can look at how much cost savings you can have. And this is a very rough calculator that you have here. And so one of the things you can look at is what's the percentage that you have for your cache hits. And in this case, if we say just 50% of our incoming prompts end up hitting that cache, what would that savings look like if we had 100,000 daily queries? And so because of that, what you can then do is calculate what your savings would be. So without caching, like we had said before, if we're hitting that LLM every time, then we're going to cost about $330,000. But with caching, even at a 50% cache rate, you're going to cut that down. And so you can see the importance of bringing in cache if you just start to play around with the numbers here. So if we just say, oh, I want a 10% cache rate, you can still see that you're saving money there. So Shruti, thank you for pointing that out. I can't believe that's a face palm for me for forgetting to show that. All's well that ends well.
Yep.
Yep. Other questions that we might have?
All right.
All right. Well, great.
Thank you all.
Thank you very much for coming. We appreciate your time. And check out Azure Managed Redis.